Let's look at the soft sign activation function. In here we have an example on the left, which is the input values x that go from -10 to +10, and these are the input values to the neuron A, which in this case is using the soft sign activation function, which is shown up top on the right hand side in the green box. The calculated values from this activation function are shown in the column A, and we can see that the negative values and the positive, there is a clear separation between the negative values and the positive values. And as the negative values go increase in magnitude, they well, they are lesser than what the original values are, but then they are again farther than the zero value. So this we can see in the blue plot on the right hand side, where we can see that the value is less than 0. They are moving away from 0 for the y-axis and approaching -1, whereas the positive values are approaching +1. Let's now look, and the magenta dots here are the values that are shown in the column A on the left hand side. Let's now see how we can use this soft sign activation in the TensorFlow. So here we'll create a set of values for soft sign, and we'll create the values that are in x. So x is equal to tf.linspace, and we are going to use the values from -10 to +10, and we need a set of 100 values. I'm going to type 100 there. Y is equal to tf.keras.activations.softsign, and inside of this we input the values of x. Now with this, what we are going to then do is plot these values. Plt dot plot x comma y, plt dot grid, and after that we have plt dot show. And let's look at the plot. So this is how the sigma soft plus activation, soft sign activation function looks like, and it's similar to the sigmoid function that we know of. And another thing we'll do is we'll calculate the values of y again based on the relation that we have up above. I'm simply going to copy this and paste it here, and for this we'll say tf.math.absolute, and so that's the value of y2. We'll print those values. Plt.plot x comma y2, and it should be an overlay of the plot. So it's an exact overlay of the values that we had earlier in the blue line. That's how the soft sign activation function looks like. Why don't we create a plot for the sigmoid function? So y underscore sigmoid is equal to tf.keras.activations.sigmoid, and this takes in value of x. We'll comment this one out and label this as the soft plus. So label is equal to soft plus, oh sorry, soft sign, my mistake. This is soft sign, and we'll create a similar plot for the other one, which is y underscore sigmoid, and that's the label we'll give here. This is going to be the sigmoid activation, and when we create the plot, we see the differences, and the difference is that the sigmoid function approaches negative values approach 0, positive values approach 1. In this case, the negative values tend to go far beyond 0, and the positive values, in this case, they are below below 1. Let's try and see what happens if we increase these numbers. Does that make any difference if we have much larger values? Of course, the sigmoid will squish between 0 and 1. And as we can see, the activation function soft sign, it tends to squish between -1 and +1 range, as we see here. So that was it for this video. I hope in this video you got some visual intuition about how how this soft sign activation function works, and how it compares with how it compares with the sigmoid activation function. If you have any comments or suggestions, please do let me know in the comment section below. I hope to see you all in the next video. Please like, share, and subscribe. Thank you.